Hello and welcome to my YouTube channel, The Intersection. In this video, I'm going to go over the concept of Pushdown Automaton, or PDA. We have seen NFA before, and NFA has a very limited capacity to keep things in mind or in memory. Therefore, we cannot recognize a language in this, let's say, A to the N and P, B to the N, and something like that. We cannot recognize a language like that because the NFA and DFA has no way of keeping count of how many A's and how many P's you have read in an input tape. So therefore, the Pushdown Automaton, it's an NFA plus a stack, and the stack is a linear data structure, and last in, first out. The stack has no limits to the number of elements that can be stacked in it. And then only the topmost elements can be accessed at any instance of time. At any instant of time, only only the topmost elements can be accessed. To see it in a vectorial fashion, here's a state control. The state control might have some different states and transitions, and it will read the tape. And if you look at the state control on the tape, that's exactly what we studied in NFA and DFA, but it is an NFA, of course, non-deterministic. And then it will either push to the stack or pop from the stack. And if it pushes from the stack, and this is going this way, if it pushes to the stack, it's going to push to the top, in the top. And if it pops, it will pop the first elements at the top. Okay, so a stack has its own, and it also a stack has its own alphabet symbols, and it is called the alphabet or the alphabet, the stack alphabet, and it's denoted by gamma. To see the formal definition of the Pushdown Automaton, you can look at the table in your book, definition 2.13, and you can see all the elements, or parts of what consists of the tuples that defines the Pushdown Automaton. All right, one more thing I want to say before we leave this topic. We are going to say that stack has two operations: a push operation, as you see here in this picture, and a pop operation, as you can see. So popping meaning removing elements from the stack, and pushing means adding elements to the stack. Before I go over exercises, I'm going to go over some of the transitions that you would see in a diagram for PDA. And here we go. The first thing, that how you read them and see them. So you might draw a transition like this, and that's what it means. It means that read the tape, pop, remove B, and push nothing. That's what this transition, and then move from Q0 to Q1. This transition means read the tape, read A, pop nothing. So always the first operation is here in this part here is popping, pop nothing, and then push C. In this operation, read the tape, it's an A, and then pop nothing and push nothing. Okay, and then move from Q1 to Q2. In this here, do not read the tape anymore. Pop B and then push C. In this case here, read the tape A, pop, remove B, push, add C, and stay in Q1. In this case here, do not read the tape, pop A from the stack, and push nothing to the stack. So always this here, this here, when you see it like whatever it is, A, B, whatever the value is, this has to do with the stack. Always the first the item to the left is popping, and this is pushing. The other state diagram that we will see in the PDA is exactly the same, is no difference. So now let's do some of the exercises. In this exercise, we're asked to construct a PDA for a language set of a to the power n, b to the power n, and n greater than or equal 0. So the first thing is you should do is write some examples of this language. So this language can be nothing because n greater than or equal 0, right? Or nullable element there, or a, or b, or a, b. And of course, in this case here, we want them to be in sequence. So A is first and then B is second. And A, B, same number of A's, same number of B's, but A is first and the B is second. And then let's say like something like A, B, 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 B. So always imagine or draw the, or write the, what are the possibility for a language such that. Okay, so now we know that we need to do a PDA, of course, in this case, because we need to count how many A's first, and then whatever, then the B's comes the second. So our strategy is if we know the numbers of A's that we pushed into a stack, then we need to have the same number of B's. So if for every A that we push to the stack, when we read the input B from the tape, we need to remove one A. So same thing that we did in NFA is we draw our state diagram like so. So here's a Q naught. And in my way is the first thing I do, I put of course we have to imagine that the stack looks like this. Here's our stack. So we need to know, okay, when we reach the end of the stack, okay, we need to know when we reach the end of the stack. So the first thing is I usually push a marker. I use a $sign. Some people use Z naught, whatever. Some people use pi as a marker there to the bottom. So I'm going to push that to the bottom. So the first thing I do is I read nothing from the tape. Okay, nothing from the tape. Then I pop nothing, because I'm not going to pop anything because at the beginning it has nothing in it. There's nothing in there, right? And then I push the $sign. So I push this $sign there. That's my first thing. So and then I move from Q naught to, let's say, Q1. Once I'm at Q1, then I need to read my tape. And my tape should show, let's say if I'm doing this here, the tape will have the tape. Of course, tape's always infinite, not finite, not infinite. Okay, so here's my A, second A, B, and then the second B if I'm doing this testing with this word there. So then I'm going to read my A, and then I am going to add to the stack. Add to the stack an A. So I am going not to pop nothing and push an A to the stack. So that's my first A. And I'm going to go over this, stay on this Q1, stay in this Q1 until I read the second A, and then I push it to the stack. While I'm reading the second A, I'm not popping anything from the stack. And then once I am done with the A's, I will read, I'm not going to read from the tape. Okay, and I'm not going to pop anything from the stack, and I'm not going to push anything to the stack. So I am right here. Now I am going to come to the next state that this transition will take me to from Q1 to Q2. 2. And then in my Q2, I'm going to start seeing B's in the tape. So I am going to read input B, comma, and now I'm going to remove or pop an A, and then push nothing to the tape. And that's how I will do this process. So for every B, I will remove an A and remove an A. Now I'm here at the end. So this one is, when I am here at the end, I am going to read no more in the tape. There's nothing in the tape here to read anymore. Okay, and I am going to pop the $sign and then push nothing into this stack anymore. So it becomes a new stack, nothing in it. So this one will be gone too. And here I am at Q3, and that's my accepted state. So this language, I would say it's accepted. Okay, now let's look at another example. This is the same example that we did in the previously, but in this case, the A's and B's do not have to follow. So you can have an AB or BA or BBA, BAA, as long as the number of A's and the number of B's are the same. Okay, so how we approach something like this? First thing is, let me draw this stack, because I need to do it many times just to show you. Here's our stack right here. So our starting state, Q0. First transition is I am not pushing anything. I'm not reading the tape. So my tape is, let's put the tape right here. Okay, so we said we're going to do this, B, or this one, how will we do this one? BB, A, B, A. So I had 1, 2, 3 A's and 3 B's. And the first transition is read nothing from the tape, then pop nothing from the tape, and then push a $sign. So that's the first thing. Here's my $sign, my marker. When I reach here, I know I'm at the end in an accepting state. Now, I'm going to be in the second state. Here's Q1. Q1, I am reading a B. So if I read a B, I need to push a B. So that means I am not popping anything from the stack, but pushing a B. I'm going to do this again. So here's, I am reading a B, second item there. So I am pushing that B to the stack. So popping nothing from the stack, pushing the B in the stack. Now I am reading an A. So when I read an A, I am going to pop a B, because there has to be the same number. I'm starting with a B. That's why I start with the B's. If I am starting with an A, B, B, A, then I will push the A's first and then pop the B's. Okay, so now I'm going to go, I'm going to pop a B and then push nothing to the tape. So the topmost will be gone. Okay, now I am at here. At this B, I'm going to push a B. Let me just do it one more time here. I'm going to draw this again. So here's my $sign. Here's the top B that I have, because this one is gone. So I'm reading another B. I am going to push this B back in there. So this is from here. Now I'm going to read an A. Here's the A. Now I'm going to, every time I read an A, I'm going to pop the A. So pop the B. So this one will be gone. Okay, I'm reading another A. I'm going to pop the B. I'm reaching the last B there. So now I'm going to go into not reading anything and not popping anything and not pushing anything. And I am at my final state. Now, what somebody might ask me, what if the process is we're starting with this A? So I'll do it this way. I'm going to go when I, and again, it's going to be like also looped like that. So I'm going to say if I am reading an A, if it's this string, not this string, not this string, this string. I'm reading an A, I'm going to pop nothing from the stack and push an A. When I read the B, I'll do the opposite of this. When I read a B, I'm going to pop an A and push nothing. So when you draw the state diagram, a complete state diagram, you have to do it for the two possibilities, because we're dealing with A to the power n, B to the power n, and we don't, when they don't have to be in sequence, so you don't know which one in sequence. So the best presentation for this problem is I'll do it as follow. I'm going to start with my starting state, Q naught, Q2, Q3, my accepting state. So in my, let's do the transitions, all of them first. That's the first thing I put on the stack. Now I have to do all the possibility, whether I'm starting with a B or starting with an A. So the best way to present this situation is, let's say, start with an A, then pop nothing and push an A to the stack. Starting with reading an input A. Next thing, reading an input A, popping a P and pushing nothing, and then a B, popping nothing and pushing B, equal to this statement. And then the last one that you need to put in there is if you read a B and you pop an A from the stack and push nothing. So this here, you have to have those. If you're asking an exam or a test, you have to put all the possibility, because we don't know what are we going to start with a B like. But if you're doing it for this case, for example, if you're giving in an exam that write a state diagram, a PDA state diagram for something like that, for this in particular, then this will be satisfied. Will satisfy the situation. All right, let's look. Before we go on to the next example, I forgot to write the transition from Q2 to Q3, which is this transition. And so this is the, as I said, this is the best way to represent a problem with A to the power n, B to the power n, where you don't know which element you're reading first, whether it's an A or a B. Let's look at the next example. In this example, we're going to construct a PDA for the language A to the power n, B to the power m, and C to the power 2n, and m and n greater than or equal 0. So for every A, I have 2 C's. That's what this 2n means. 1A, 2 C's. And as you can see here, 1A, 2 C's, 2 A's, 4 C's. The B's, it doesn't really matter. My strategy, I'm not going to focus on the B's, because I don't know how many I'm going to read, because M can be 1 or can be a million. But A's, and if A's is 1, then I know C is 2. If A is 2 A's, then I know I'm going to have 4 C's, and so on and so forth. So I can rely on that. And so here's my tape that I'm going to read, and here's my stack. So the first state, let's just keep looking at the problem here. Okay, I'm going to go like that, and then here's my starting state. my starting state. I am not going to read the tape. I'm going to not pop anything from the tape, and I'm going to push my marker to the tape. So here is, that's my first. Let's put it right here. Here's our starting state, Q naught. Okay, this is our first transition. I'm going to transit to Q2 or Q1. And in Q1, I'm going to read my first A. When I read my first A, I'm going to pop nothing from the stack and push an A. So this A here goes to the top of the stack. I'm going to read the second A. Second A, push, pop nothing from the stack and push an A to the stack. So here's my second A. So now I have this situation. Now I'm at the B. So to transfer to the next state, I am going to not read anything from the tape, not pop anything from the stack, leave the stack alone. I am not going to push nothing to the stack. I'm going to come to Q2. Now I'm reading the B's. So every time I read a B on the tape, I will push nothing to the stack and pop nothing from the stack. Oops, this one also goes like that. So because I really don't care, that can be 10,000, can be 10 million. I don't care for how many B's in there. Of course, you have a finite. Don't forget the tape has to be finite. Now, next thing is going to the next transition. Next transition will be reading nothing from the tape, because I'm right here. Reading nothing from the tape, popping nothing from the stack, pushing nothing to the stack. And I am right here. Now, in this case, for every 2 C's, I have represented by 1A. So I have 1A, 2 C's. And this is this A. So these two represent this A, and these two represent this A. So how do I solve a problem like this? I'm going to go to a next state. Let's say this is Q3, Q4. When I read a C, I'm reading a C. What I'm going to do is I'm going to pop an A and push nothing to the stack. So this A is gone. Okay. To transit from Q4 to Q3, again, I'm going to read this C. Okay, this is the C is red. I'm going to read this C. When I read this C, I am going to pop nothing from the stack and push nothing to the stack. So the stack stays on its situation. Same, that A stays there. I'm going to come, I'm still reading a C, C's. When I go here to go to Q4, when I see this A, when I see this C, I pop the A and push nothing to that. Okay, so I'm right. This A is gone. So if I go from Q4 to Q5, when I see this, the C is gone. When I see this C, then I am going to, Allahu Akbar, I am going to pop nothing from the stack and push nothing to the stack. And so I'm still the same here. Now, next thing is I'm going to go to the accepting state, Q5. In this, I have this, there's still the marker dollar sign there. So I'm not going to read anything from the tape because I'm done. Nothing on the tape. Then I'm going to pop the dollar sign and push nothing to the stack, and the stack becomes ready for the next operation, and I am done. I am at the final state. All right, hopefully this will help you. And let's, in this example, we're asked to construct a PDA for the language A to the power N, and then constant number of B's, 3 B's, and then A to the power N. So N is the same, so A, B, B, A is accepted. A, B, 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 A is accepted. So the language can be, and it cannot be epsilon, so that because greater than or equal 1. So the language can be A, B, 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 A, 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 B, 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 A, 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 B, 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 A, and so on. But as long as B's are 3 times. All right, how would we do this? So we're going to start with our start state. Reading nothing from the tape. Popping nothing from the tape, from the stack. Reading nothing from the input. Popping nothing from the stack and pushing the marker, the $sign. Now we're here at Q1. At Q1, we are going to read the A from the input tape. Let's use this as our example. So our tape is A, again 3 B's, and then A. And that's the end of my tape, and here's my stack. Here's my $sign that I pushed into my stack. Okay, so I'm reading the A. When I read my A, then I will pop nothing and push an A. So I'm going to do this 2 times. I cannot do a loop when I go to Q2. I can't do a loop because I have a constant number of 3 B's. What I can do is I can do read a B here, read this B, and pop nothing and push nothing to the stack. So that's my first one, and I'll do it again here. Complete my stack, so you can, here I have 2 A's, and in this case here I'll get rid of this 2 A's. With this step I get rid of the marker there. Don't have any B's because I'm not pushing any B's to the stack. Sometimes you see this like this. You'll see it like B, pop an A, push an A. So that's like doing nothing. That's exactly the same thing. That's exactly the same thing. So you can see it sometimes B, pop an A, and push an A. So I'm not doing anything to the tape. I like to represent it this way, much clearer than this way. So when you push an A and then pop an A, you're pushing an A and then popping an A. It's almost like it's exactly the same thing. You're pushing nullable value and popping nullable value and pushing a nullable value. I hope this is clear, this kind of an exercise. This tape is getting so long, this video is getting long. I'm going to stop right here. Wish you the best of the best, and enjoy your break, spring break, and I'll see you after the break. And do subscribe to the channel so you can get all the updates.